Nice to meet you. My name's Aaron. I'm going to skip out on most of the who am I and what do I do sort of thing because there is a lot to talk about and I don't think I have a lot of time to do it all. So let's move forward. So about this talk, this kind of started on the notion of I want to know the answer myself and I couldn't find a clear cut answer and it gets a bit muddy as you dig into it. So it makes sense. Like, what is the answer to this question is, well, if it's in the same mesh, use mutual TLS. That is a well-documented path forward, and it is easy to understand and read. But what happens when it's something like within your mesh that's trying to talk to something outside of your mesh? Or what if it's something outside of your mesh that's trying to talk to something within your mesh? That's where it becomes a little less clear cut, a little bit harder to understand, and a bit more of choose your own adventure style book. And so I wanted to figure this question out. I want to find some answer to it and then present what I learned. And I'll admit I'm still learning. Like there's still a lot that as I'm learning myself, I'm finding more information to be had. And I know this analogy has been used to death, but I'm using the iceberg analogy. I know, hold off on your booze. I do apologize. It makes sense here, though. Come on, you have the mutual TLS as most we'll see in with a service mesh, but you go down deeper, and once you start trying to get other things from the outside world connecting in and authenticated and authorized, it gets a bit murky. So for every use case, or for most of the use cases, I want to have some sort of pattern or tools or something that might make sense to be put into place to fulfill that function. Now, before I go too deep into this talk, I do want to clear out some potential confusion. Like, if you already know what authentication and authorization is, great. You can probably take a nap for 2 minutes, coffee break, go on. I'll see you in just a second. But if you don't, what is it? Think of it kind of like you're trying to buy a drink. So you'll have a driver's license that you get from a DMV, and that is a form of identification. That is something that was created from the Department of Motor Vehicles based on some information they got about you. And then when it comes to you being in the store trying to buy a drink, trying to buy some alcoholic beverage, they are going to check your license. They are going to take a look at that picture and the license. They're going to compare it to the person in front of them, and that is authentication. They are checking to see that you are you based on what they have received. Then authorization is, are you allowed? Based on this age that is on this card, are you allowed to be buying this White Claw or Kentucky Bourbon or whatever is your beverage of choice, or not, because you're not supposed to be there. Get out of there. So moving on, because this can get deep. I don't want it to be, because we don't have a lot of time. But keeping at the surface, Istio provides a form of authentication and authorization by default, or within the mesh, and that is using mutual TLS. So whenever you have a pod or multiple pods that are controlled by Istio, they are having containers that are injected into those pods. They are sidecar containers. They are proxies that Istio is able to then take control over. And with that, it's able to give them policies. Like, what are they allowed to do? What are they authorized to do? That is authorization policy. And then using mutual TLS, well, they give each of these proxies certificates of who are they and how do you encrypt using them. And also the keys, and also a certificate authority has signed off on them. And both of the proxies in both these services have a certificate that identifies who they are. And that is the authentication piece of it. So whenever proxy A tries to talk to proxy B and it's using mutual TLS, it is sending with it a certificate that says who it is, and how to validate it is based on that certificate authority from the control plane, which is IstioD here. And then based on the authorization policy, some configuration we pass to it, to the server here, the thing being called from IstioD, some policy that says you are allowed or disallowed depending on who you are or what you are. Now, I know most of you have probably seen this image already dozens of times, but I do want to call that out because that is our surface of the iceberg. We are at the top, and it is quite visible. But the auth in and Z portions of this, authentication, authorization, come in, as you probably guess, pure authentication and authorization policy. So here, we are forcing it to, you have to use that certificate using mutual TLS if you want to authenticate. If you want me to know who you are, you have to give me this cert. So it is usually for encryption, but it is also for authentication. And then you have the policy, the authorization policy. What is this going to do? Well, based on this spec here, we're going to say no. We're going to deny it if it's traffic going to the foo namespace here. And if the rules are, if the thing that's trying to access it is from the dev namespace, and that is from that certificate that's been passed in, and is trying to hit the post endpoint or use the use a post method, then no, say no. Now, there's a few other authorization policy examples here that we can do, and go a bit more extreme, and then more extreme after that is we'll start with the left here. So if it's a pod that it has this label set of app and my API, and it's in the namespace one namespace. I know, clever naming, right? I've grabbed most of these examples from Istio and made a few myself, but nevertheless, if it's going to be enforced here in these labels on this namespace, and it's going to allow, well, pretty much anything as long as it's a get method to this endpoint, which is /user /profile /something. It's a wildcard. Going a bit harder, a bit more complex, we have enforcing on pods that have this set of labels: app HTTP bin version v1 on the foo namespace. We're going to say yes, we're going to allow it as long as it fulfills these rules here. If it's coming from a namespace of default and a service count sleep, then it is doing a get method and it's using using headers with the values v1 or v2, then the key version, then yes, allow it, let it in, free to go. Now, this is the part where it gets a bit murky, and it's going to continue getting murky. But the first murkiness is, what if it's your service that's in the mesh is trying to talk to something outside of the mesh? Most of the time, you're not going to have control over this external thing. It might be a SaaS, it might be a vendor's load balancer, it might be something else. In that case, it makes sense just to use what that other service is offering, and just the most secure one. So it might be they give you an API key to make calls against it. It might be big auth, so using a password to get access to it. They might give you a JWT, which, oh yeah, but it's going to be up to them. That being said, if you do control this, like if you have the ability to administer this virtual machine that is not part of your mesh, then you also potentially have the option for mutual TLS. Now, it's going to be a little bit different, where before we have, we're using mutual TLS here. It's going to be using just what Istio provides. We're going to be using something a little bit different. Wherever it goes to the destination, instead of Istio providing that mutual TLS, it is you kind of putting in your own. So certificate authority certificate here is going to be dictated on what is a shared trust between the thing in the mesh and the thing outside of the mesh that you're trying to contact. And then a certificate and a key to kind of identify yourself and do that SSL piece of it, or TLS piece of it. So it is similar. That being said, you do have to share some private keys from the thing you're trying to call to the thing within the mesh. So there might be some use case, but I'm also a little hesitant on it, and I might just say probably fall back to whatever the external app is telling you to use, because but again, if you control it, then you could decide if this makes sense for you. And in this scenario, it might make sense, like in at least with Google's cloud platform with their Cloud SQL, they'll very often give you a certificate authority and a certificate to like connect to that database. It might make sense here to use that, at least to form that connection. Then I believe the actual connecting to the database itself is going to be authorized by usually a password or something similar. It's been a while since I've really worked with database things, so take that with some grain of salt. Anyway, what if something from the outside world or outside of your mesh tries to talk to something within your mesh? So you have an app in here, it has a pleasant UI, and you want to expose it to a customer, one of your own employees, or some machine that has a script that runs on a cadence of some sort. You'll want that to always go through the ingress gateway, mostly because, well, it creates a much simpler pattern. You could have that authentication authorization piece happen at the gateway itself and not have things connect to the inside from the outside world haphazardly. You have to open up new ports and make things a little bit confusing. So try to send it through the ingress gateway and then usually enforce your authentication authorization there. So to do that, usually you'll want to use a JWT or a Java Web Token. And the crux of this is it's just a fancy data structure. So this big old blob of text that is oh so beautiful. It's this is from having a service account and then running the command Google or gcloud auth print identity token. If you're using gcloud, you'll probably be familiar if you use Google Cloud Platform, but if you're using AWS or Azure or something else, this might be a little bit foreign. I'll admit. But the structure of this that it provided back to us is a header dot a payload dot a signature. It's going to be a very, very crude explanation on how a JWT works, and you go deeper into it. But the main thing is the header is information about the JWT. So how it's encrypted, things like that. And then we have the payload, and that's the main piece of it. That's the interesting piece. And I have a picture of the JWT payload decrypted here, or decoded rather. So what we have here is an audience. So who is that audience? And here it's supposed to be Google being the audience here. So this number dot apps dot that sort of thing. Who is the email that is associated with this service account? In which case I just made one Jasper at and then my project name, which is just whatever it defined. I just went ahead and used. When was it created or initiated? When does it expire? Who issued it? So we could call back to that. Accounts.google.com created it for us. And then a subject, which is a globally unique ID that we can reference, that we know that if we have another service account come in, it cannot have the same ID and be the same thing or be a different thing. And then the signature, which is the thing that makes it secure, is we could use asymmetric encryption. So essentially, we take the header and the payload, so the first two pieces, we smush them together, and then we encrypt it with a private key that most people no one other than the authorization server has access to. And much like SSH and certificates used on a website, it can be decrypted if you have the public key, and which is a thing that you just pass around freely. So with this, pulling to this other example here, you'll have an authorization server. It will create a JWT, and then it will give it to a machine, and it's signed off on it by encrypting that signature. When it comes to calling something in here, like I want to get access to, or this machine wants to get access to this here, Ingress Gateway will have a rule here that will say, based on this path, go here. But first, I want to check a few things out. I want to authenticate with it. I want to verify that this JWT that I have received is, as I would expect, is who I expect it to be. So it's going to talk to the authorization server, and it's going to check for a public key. And if it can decrypt using that public key and it doesn't look like garbage, then we know that it is, in fact, from this authorization server. So as long as this ingress gateway trusts this authorization server and this signature that was encrypted with this key can be decrypted with this key, we know we are good to go. This pattern is pretty good for machines in that if we have this Java Web Token here, this JWT, there's a very good chance that we are already living in a virtual machine. With the case of Google Cloud Platform, the virtual machines get either by default or custom a service account applied to it. Or if you're using GKE, you can use a thing called workload identity and then have a service account per pod if you want. And so you're able to use this as identity, and you're able to do something like the gcloud auth grant identity token or some similar REST request to pull that token down. And so you're able to authenticate, and it's able to verify that the thing it got is good for the authorization server. But for people, you might not have that, or you might not want to, just run something like this for every request. You're probably going to be going through a web browser, so it probably doesn't make sense to, go through the same flow. But we have a web browser, and we can consent to things pretty well. So there's other options for that, which we will get to more in just a bit. Let's see, what time are we at? 3:07. We went through. Okay, so we're doing okay on time. Okay, authentication and authorization in Istio by example. We have two configuration pieces here: the request authentication and the authorization policy. It's going to look kind of similar to what we've been doing with the TLS authentication authorization piece, but the main thing is instead of peer authentication, where we use a certificate and TLS to determine who and what the thing is, we are using a JWT using request authentication. And this is getting applied at the selector patch labels Istio ingress gateway in the Istio system namespace. And it's verifying that this JWT is legitimate based on the issuer, accounts.google.com. Now, I do want to call out that I am cheating a little bit here in that the audience was originally intended for Google and not for Istio Ingress Gateway, but that's probably fine. Like we have the signature here and it is getting encrypted and decrypted, and we can validate that it is from here. So while we are not the audience, we can verify that this is as we expect. Now, get back to our example here. With the JWT SURI, you can put something here, but OpenID Connect has a discovery endpoint where you could have a issuer, and then the default path is /.wellknown/OpenID configuration. If it can see the issuer, then it could automatically try getting to this, and if something, a public key, then we'll try to use that public key. If you don't have this set up, then we can say, well, here is where my public key is, or you can say, this is my public key. I will put it in a string here for you. And then authorization policy is taking what it learned from authentication and then saying yes or no based on it. Here we are going to allow based on the request principle. So if we are this issuer / this subject as received from this JWT, so this issuer, this subject concatenated together, then okay, cool, you're good to go. We validated, you are good to go, and come on in. That being said, you could also use claims if you want to, or you say from rules from claims, and then you can say reference the email instead. It is generally recommended, though, if I recall correctly, to use the issuer / subject pattern, because while emails on an account could change, the number itself cannot. All right, so far we've been doing that authentication piece and authorization piece all in Istio, this one included, because while this created ID, this was doing the thing of seeing who it is and then enforcing it. If we want to do the authorization piece, what are they allowed to do? We can push that out of the Istio system a little bit and add hooks into it. And what I mean by that is Instead of authorization policy saying allow or disallow, we can say custom. Let's do something different. And with the provider, we could say, well, here's the provider I want you to use to make that decision on my behalf. And this provider is going to be listed in the Istio configuration in its config map. So this will require a bit of a configuration change to Istio itself. In the config map, we'll look at extension providers, and there'll be a list. And in that list, we could add a OAuth2 Proxy or something similar. You can name it whatever you want, as long as this matches this. And then where do you go to find the information to get that yes or no answer? Here, we're going to do the service, which is a Kubernetes service, and then this port, which is a port that it will listen and respond to. So there's two main ones, two main external sources of that yes, no authorization practice that you could use. The first one is Open Policy Agent. This is not used just for authentication for Istio, but it can be used for other things, for many things, to say yes or no for CI/CD pipeline, or for SSH access, or for connections coming in from Kubernetes. Like, can this thing be validated? In fact, I want to call out another talk that's going to be coming up in a day or two called Gatekeeper or something. I don't remember the name, but there's one called Gatekeeper that if you want to go more into this here, might be worth attending. Anyway, going back to this. In this example here, we have user roles and role permissions. And in this example, we have a set of users. Here we have Alice and Bob, but this could just as easily be a list of email addresses like we've seen earlier and what roles they have. And then you can name your own roles. And then for each role, you can say, what is this role allowed to access and how is it allowed to access it? Is it a get command, post, etc.? And, this works. This means that's a configuration as a code setup. So this is this is also very programmable, meaning if you don't like how this performs, you can change it as a programming language called Rego. Just learn Rego and you can configure as you like. Anyway, this is pretty good for machines in that, to make this change, it is a configuration push and a new deployment. You have to deploy the changes. So with things that don't change a lot, like machines to your service, probably fine. To employees to your service, maybe also fine. Because very often you go through a change management process for either machines or employees coming into your workplace to do various things in your network. So you could say, well, this process is allowed to do it because this process is part of this group. This group's part of this, is able to access this thing. And same with people, you can do that as well. And it would follow the as configuration setup like we would see with Terraform of infrastructure as code. You will have a policy as code sort of setup. And because it is deployed separately from Istio, that means you can, in theory, give it to another team who can be specifically in charge of dictating who's allowed to access what. And then you can set it through the service management process to say, well, this person needs access to this thing, or this person needs access to this group to access this thing, and then that group of people, that other group can make that change for you. All right. So we are pretty deep into iceberg if we're going back to that analogy. So OAuth2 Proxy is something I find pretty exciting. This one's great for humans because it does follow the three-legged auth where you say connect to a thing and then it authenticates using the other thing and authorizes on it and then sends it back to the original website and then you go about your merry way. And OAuth2 Proxy is just that. It is a proxy for OAuth2 / OpenID Connect things. And sorry, and your where you work, you probably have some sort of LDAP or some sort of grouping of people that have to log into something already. And because there's a lot of plugins or a lot of ways to set up OAuth2 Proxy with various providers like Google or Azure or GitLab or GitHub, you could just tie what you have in currently for your service mesh and that to what you have currently in GitHub or GitLab or Google or Azure Active Directory. You'd tie those pieces together so that one can dictate the other. So going into a bit of an example here, hold on, how much time do we have? Okay, not a lot. I'll try to speed up a little bit. So going into an example here, I set up with my own just GitLab because I have a GitLab already, and this wasn't too hard to set up. So you could have a group, for instance, and you could say this group could have this set of people attached to this group, and this group can access this particular endpoint in the service mesh. And in the configuration on the OAuth2 Proxy side, this is the thing that gets deployed into the cluster. You'll have the provider, which is GitLab. You'll have the redirect URI, so where to send the request back to you once we log in. And then a few things like client ID secret, and then cookie secret, which is a thing that you just get decide here. The client ID and secret is dictated from the GitLab configuration. So on the GitLab configuration, you go to GitLab and groups and settings, applications, and then you could actually connect them. The setting is pretty straightforward. It's the name, the where to redirect, and then a few settings like OpenID and profile and email, so it knows who it is and what groups they're part of. And then once you save it, you'll get the ID and secret, so you can connect them together. And then you can actually restrict like what groups can access this particular thing. As long as the JWT that it receives back whenever it logs in is part of that group, then we're good to go. And then if you have GitLab that is that's self-hosted or in the cloud, you could, like if it's self-hosted, you could dictate that it's self-hosted and not a cloud-based solution, or it's not their own SaaS offering. Now we could extend this a bit further if we wanted to, where we can have the configuration not for employees, but for customers. It would be safe to assume that your particular app that you want people to access will have different authentication or authorization needs should be dictated by the logic of the app itself, and should be able to do basic things like this person can access this organization, or this person has these personal preferences. That some of that logic doesn't fit well into Istio, because Istio is a bit more general. It could work with paths, it could work with JWTs or headers, but to go into app logic, we probably want to do that authorization piece in the app itself. But we can have Istio do the authentication piece. And in this example, we are having Istio, its ingress gateway. Yes, you are allowed to, or you are this identity. I know you are this identity because I checked the issuer, I checked the public key, I decrypted that signature. You look good. And then I want to forward you on to the next thing that happens. And then we'll use a, not shown an example here, we could use a virtual service to forward that traffic onward. You forward it onward to the Nginx backend. And then the Nginx, or probably more accurately, whatever app you program with very specific logic, can consume that JWT. So the authentication piece that's already been done, we have validated that this is what we expect it to be, but we got that JWT, we read it, it says user is Jasper at, I forgot what I named my project. Anyway, based on that, I can say it's allowed to check this out, not check this out, based on whatever I program in the app itself. Now, a little bonus, and I know we're running a bit low on time. I do apologize. Try to speed up. But what if we have another app in a virtual machine or something similar that's not part of our mesh? And the thing in this mesh could, in theory, talk to this thing in the virtual machine, but not from the outside world. And we want to add some sort of authentication, authorization to this, but we don't want to put it into the app itself. Well, I mean, if we already built up the solution in the ingress gateway, And the proxies are just, proxies. We could send traffic to the virtual machine. So route traffic to this virtual machine through the Istio Ingress Gateway first. Let it do the thing of who are you, what are you allowed to do, authentication, authorization. And if it all checks out, then you can forward it to a path that we dictate to send it to this virtual machine, or more specifically to this load balancer to the virtual machine. So you can reuse the same solution for the thing outside of your mesh that you control. Now, some of you might be thinking, well, what about API gateways? I already have one. Why do I need Istio Ingress Gateway? And to that I would answer, good question. I don't know. But okay, I know a little bit, but not everything. The main thing is, like, API gateways, they'll usually have a bit more functionality than Istio Ingress Gateway by default. And to get some of the same things you would have with API Gateway, you might be able to get away with adding some plugins that honestly I don't know if they exist. But with API Gateway, you'll very often have a way to do billing, like charge based on the request that came in, or say don't contact me more than a certain amount of times based on a quota, or do some data transformation, like a body of text comes in, do a little bit of tweaking before you send to the backend. Istio Ingress Gateway is probably not going to be good for that. But if you don't need those things and you have API Gateway, or you don't have one already and you don't need these things, then maybe it makes sense to put things in the Istio Ingress Gateway instead. Or maybe it makes sense to kind of just share that responsibility of the API Gateway behind the Istio Ingress Gateway, and then share some of that responsibility. Like the Istio Ingress Gateway could do some of that termination of TLS, or it could do that validation of the JWT token, or it could do some load balancing. Well, yeah. Okay, maybe not so much if you're putting that behind it, but you could share some responsibility if it makes sense to do so. And there's plenty of solutions for API Gateway. I can't vouch for all of them. So in summary, I guess general recommendations, if we are talking from thing to thing within the mesh, just use mutual TLS. It is simple, it is secure. I would recommend it. It's mesh to non-mesh. That's going to be very muddy. Just stick with whatever the other app is using for auth. Use whatever is most recommended or the most secure option there. But you also have mutual TLS as an option if you have control over that other app. If it's machine to mesh, use a JWT token. If it's living in a cloud, also even better. You already have an authorization server, very likely. Again, I might need to validate that on AWS and Azure, but Google Cloud Platform, good to go at the very least. Employee to the mesh, you can either use Open Policy Agent or OAuth2 Proxy, depending on if you want more of a policy as code setup, or more of a already want to only use my existing LDAP solution setup. If it's a customer to the mesh, then OAuth2 Proxy or API Gateway, depending on what you have already and what makes sense for you. You can reuse the Ingress Gateway to something else that you control that's upstream if you don't want to put that same thing into that same app. Just reuse what you got. And then API Gateways, use them or don't. That's totally up to you. Now, I want to thank you for coming and bearing through all of that. I know we only have, well, about a minute. So I don't think we have a lot of time for QA, but Rose, I guess it'd be up to you to decide if we want to stick around or just continue with this on the IstioCon chat.
Yep, no problem. Let's go ahead and answer a couple of these questions.
Sure.
All right, so we'll start at the beginning. We had a question from Mikhail.
Okay.
What is your take on using OPA to describe the authorization policies? And then he linked another blog for reference as well.
Okay. Do I have access to that blog from here? I haven't actually checked that.
Yep. Let's see. It's a Styra blog.
Hold on. Let me stream content. Oh, there we go. Let's open that up. Oh, no. Wait. Is it on? There we go. Thank you. Traffic policies. I actually haven't read this one. Let's see. And I don't think I'll be able to read it quickly enough to have a... Well, yeah, I don't remember seeing this diagram here. I like it, but it really depends on use case. I hate to say it depends, but it kind of depends on what makes sense. OPA is good for configuration as code, but I'll be honest with you, I haven't dug too deep into that solution other than using something like Gatekeeper for emission control with the Kubernetes API, and not through not for request authorization. I'll admit, when it came to Rigu, and I still cannot pronounce that, or I know I've learned it to some degree, and I've cursed at it to many more degrees.